Hello everyone, today I'm going to be talking about the third revision of my ant-weight combat robot, Circus. So this is Circus 3, third revision. And if you've been on my channel a lot, you know that I changed the robot a lot between competitions due to not a lot of success. It's kind of just how things go, but this robot has quite a lot that's changed on it, and I will get to that, and you'll see it has a different drive system, different wheels, different materials, different weapon. It has quite a lot, and I'm still waiting on a lot of parts, but I'm going to show you what I have so far. So this is my test chassis. Ignore this motor, it's just going to be dangling here. I'm not going to be using that motor. So we have these wheels. I'm going to mostly be talking about the drive for this, but I'll get to some of the other parts later. But yeah, so we have these wheels, and the first thing you're going to notice if you've seen my other version of Circus, these wheels are inside the chassis. See, they're inside, and if you remember my last chassis for Circus, the wheel was out here, and we had a gear motor. That's not going to go in there. It kind of looks like this. And there's a lot of problems with that. First of all, your wheels are very vulnerable. It's not hard for a robot to just come around to the side and just take your wheel right off. So that was one issue that I was pretty worried about. And I did have problems with the wheel falling off, just not good things. So there's quite a lot of things here that have been done to fix that. Main thing being, I put the wheels on the inside, so these cannot come out. They're trapped in there pretty good, multiple reasons. So we have, you can see there's a lot of plastic surrounding this gear motors. So it's actually in like this bay thing that's trapped in there, and the gear motor cannot move. It's in there. And yeah, I'd be able to show this, but it's quite a lot of disassembly. I think I'll show that in another video, hopefully. But yeah, so gearbox cannot move, and the wheel is in there, and there's also this shaft support. So you can see the motor shaft. It's in there. You probably can't see that, but it's up against this wheel. It's holding the shaft, so whenever this takes impacts, the impact will be taken both by the gearbox a little bit, but also the shaft support. The impact will push up on this support here, and it'll absorb the impacts, theoretically. So that should save my gearboxes from being destroyed every time it takes a hit. Let's see how that goes. So yeah, that's kind of how that is. You may also notice that the wheels are smaller. So here's the original wheel. The red one is the original next to the white one, which is what I'm using now. So this was 5 centimeters. These are 4 centimeters. And I just had to do this based on the design that I was doing. So this way it fits inside the chassis. I'd probably have to make this bigger and maybe even come out more in order for the 5 centimeter wheels to fit on here. So that does mean I am losing speed. I think these are faster motors, and I'm looking to getting a speed controller that can do up to 3S to make this go faster. But it's also for when it gets upside down. The weapon motor that I'm using should have the shaft that goes like right to the bottom, so it should be parallel and not turning everywhere with the weapon. Anyway, so you may also notice that they are white, and it's not because I painted them, it's because I'm using a different plastic. So I am no longer using the red ABS that I've been using for the past like a year or so. I think, yeah, it's about a year. So I'm now using ABS plastic mixed with polycarbonate. So it's called PC ABS if you want to use it yourself. Polycarbonate has been known to be one of the strongest 3D printing plastics that you can get. It's used for like bulletproof glass. It's used to make that. And so this is actually a mixture of polycarbonate and ABS. And at first thought, you might think that the ABS is just for printing, more printability, make it easier to print, because polycarbonate is notoriously very difficult to print with. And yes, the ABS does make it a lot easier to print. But however, this surprised me too, it actually does increase the strength of the polycarbonate. It makes it stronger with the addition of ABS. So that's really good. It's going to be really impact resistant. It's going to be able to bend a lot before breaking. Polycarbonate ABS is very strong. So if you take a piece of ABS from the spool and you bend it just enough, then it'll snap in half. Polycarbonate, you can like bend it and like push it against itself and it won't break. And I had to bend it back and forth multiple times and then it snapped. So it's very, very strong. I don't think I'll have a lot of problems with it unless I get hit really hard. So I use that for my wheels. And this chassis will also be made of polycarbonate ABS. Right now this is just PLA, it's just a test chassis. So that's pretty cool. So yeah, that's where the drive is. Other than that, not a lot of new parts that have come in yet. I have a lot of stuff that's coming in. Oh, I forgot to mention, these are actually not N20 motors. These are actually N30 motors. So this was the size of motor that I was using before, and this is what I'm using now. You can see the length difference is pretty noticeable. So this provides, I think, 20 to 30% more power overall. So just that extra little bit of power, it's always good to have. So I think what I have now is an 840 RPM motor. So it's got some good speed. Like combined with this, it gets around. It's not the fastest robot, but it'll get around. So these, what I got, I think they're like 120 RPM motors, and these are, I think, 840 RPM gearboxes. So I actually took the gearboxes off of here and swapped it with this. So this motor has the gearbox off of this, so it's a pretty quick motor. That's what I have on here. I had to do a little bit of modifying on the motor shaft, and I had to shave down the gear in order to get it to fit, because they're different gearboxes. But I got it to work eventually, so that's pretty good. So yeah, time to talk about the weapon system. So before, this was my weapon system. I used a pretty tiny motor and this decently sized weapon. It was 100 grams and I could spin it up to almost 30,000 RPM. And when I did it just right, that weapon hit very, very hard. I had people commenting on like how hard it would hit, and I was pretty happy with that. It could have gotten some better bite, so I'm actually moving back to this diameter, but I'm also doubling the speed of my motor, so it spins up to 8,000 RPM, and so it's gonna, the bite won't be as high, but it'll be better than what I was using before. And also it's gonna pack a lot of energy and we should be hitting pretty hard. This is a 150 gram weapon. I might use it. You can see it has 2 teeth, but traditionally I usually use single tooth weapons. They have better bite and they can get more engagement, and they usually hit harder. They're just better weapons. If you can design, if you're making a spinner robot and you can design a balanced single tooth weapon, do that. I might have a tutorial coming soon on how to make a single tooth weapon on CAD. Stay tuned for that. So what I'm trying to say is I'm probably not going to be using this. I might, if I want to hit more conservatively, I guess, I might use this, but I have two 150 55 gram weapons that are on the way that are a similar style to this beast right here. It has a single tooth, but it has actually a thicker ring on the outside, except it's actually a 3mm thickness of weapon. So it should have some decent kinetic energy. It should have a decent balance between slicing and cutting. I found with this weapon and also this weapon, this is a 4.7mm spinner. This is a 6.3. They more bash than cut, right? For anything, and I think that if I want to actually cut into robots, I need to have a thinner thickness. I think this would be a better. It has a good balance between cutting and delivering a hit. That's kind of what you want. So I do like these thick weapons. They pack a lot of energy, but I think I'm going to try the thinner thickness and see how that goes.
So as you can see here, we have the robot. Check all those angles right now. So as you can see, the weapon on this robot is quite large. So from this over here, you can see it takes like half of the robot from the top. So this is, yeah, like 155 gram weapon. Let's see what it was. Wait for this macro to load. Oh, that's not good. There we go. So if we go down to here, so okay, yeah, 158 grams, according to this. So we'll see what the actual weight of it is when we get back, when the weapon actually comes in. So you can see it's quite a lot thinner than the last one, but it's still got some decent thickness on it. Here you can see the motor that I'm planning to get. Well, not planning to, it's already coming in. So for those of you who haven't recognized it, that is a Sunny Sky 2806 motor. This is the 650 kV variant. So with the voltage that I'm running at, it should be able to spin the weapon up to 8,000 RPM. Decent speed. You can see we have this top plate, and you can kind of see this motor bay thing that I was talking about. The lids are off of it, so you can kind of see how it works. It's an STL file, so for the chassis, so I kind of see. Okay, that's not too bad. So if we you can see that it's kind of hard to see here, but even when it's sitting like this, it actually cannot move, because yeah, there we go. So you can see there's like this wall here. Can't show it because it turns gold. But yeah, you can see there that it traps the motor because it holds it, and then the gearbox can just sit in there. So that's in there pretty good. And then there's a lid that's bolted on, and you can see the shaft goes through to the shaft support and holds the wheel in place. So that's not going anywhere. And then all of the rectangles at the back, that's for the electronics, and I have the little extension on the left, and that's to hold a possible finger tech switch. Really hoping I can get some of those in. Really want to try them out. And yeah, that's kind of all there is to that. And yeah, it's kind of all there is to that. Yeah, I'm pretty happy with this design. I'm really hoping that this is one that actually wins. Trying to get some wins with it. But yeah, we'll see how that goes. I think it's gonna be it for today. See ya.